Hello, everyone. My name is Patrick Rhodes. I am a master's student at the University of Arizona, graduating this spring in 2022 in the Geographical Information Sciences program. This presentation will be about selecting prospective sites for previously non-riparian areas in the state of Arizona using GIS technology. Arizona is a very geographically diverse state. We very much think of the Sonoran Desert when we think of Arizona, especially if you're not from here. But if you live here, you know that there's quite a bit of variation and diversity in the landscape, such as Humphreys Peak, which is nearly 14,000 feet in elevation. And we have pine trees in upper elevation. We have some riparian areas. And of course, we have the Sonoran Desert itself. And the great thing about this state, particularly in the Sonoran Desert, is it is full of ephemeral and perennial streams. 99.9% of them are ephemeral, which means that they only contain water after a rain or some sort of flooding event. And but in the perennial streams, that's where we have our riparian habitat, which is what we see right here along the San Pedro River. Riparian habitat being that habitat which borders from dry land into wetland. Concerning that riparian habitat, it has been degrading for a number of decades. This is by and large mostly due to damming of the rivers. You can see in this table that most of the major rivers in Arizona are not free flowing. That doesn't mean they don't flow, it just means that they're dammed up and that flow is actually controlled, and that water is diverted to urban populations, and a great deal of it actually goes to agriculture. So what that has caused is the riparian habitat to degrade significantly. For instance, well, let me back up. The way we battle that is through restoration. What they do is we open up the dams from time to time. We try to flood these areas, and then, to keep the plants there sort of going. And it doesn't really work. What ends up happening is that the native plants there, the cottonwood willow and the mesquite, end up getting replaced by plants that can handle the drought in between those flooding efforts, which is tamarisk. And it does not look at all what the non-native or what the native species actually look like. You can go out there and see it for yourself. This is what mesquite trees used to look like in riparian areas. This one is 72 feet tall. Try to find one of those out in the desert today. So the goal here then is to perform a suitability analysis, which tries to locate areas or dry riparian areas, or areas that are current washes, where we can convert them to a wet riparian area, which will be, so they're located in ephemeral streams, and they would require damming and lots of equipment to make this sort of thing happen. It would be a 100% artificial solution. The study area, of course, is in the state of Arizona, and it's great because it's arid environment, which means that riparian habitat is vital to this state in terms of wildlife. And of course, the rivers, of course, are vital to human habitat or human populations as well. It has a ton of public land, which we're going to see ends up being very, very important for this kind of study. So there's lots of different sites where you might locate something like this. And of course, I live in the state, which allows me then to go visit these areas personally and perform some ground truth field work. So in terms of the data, these are the selection criteria I use. And this is based on a pretty extensive amount of research, which has been done in the past. So the criteria are, of course, within the state of Arizona and on state trust land, which is greater than 100 acres and non-leased. Why state trust land? Because state trust land is publicly owned, and they work with universities in K through 12. There's some funding there available. So maybe there would be some funds to start this thing initially. I wanted it greater than 100 acres because I don't know what equipment would actually be needed. That would allow room for storage and fencing and a number of other things. Non-lease means you're not competing with other applicants. The ephemeral streams, I want to be at least 2 miles in length, which gives you enough room to sort of locate inside that 2 miles where you might want to locate this an artificial riparian area, and within current flood zones. You want to build this thing in such a way where when a flood does occur, that the damming allows that water to be flushed out and then replaced with new nutrient-filled water. The criteria in orange there, historical fire boundaries, I use that for this project, but the reason it's in orange is because we're going to learn that that's not actually an important consideration, and I'll talk about that later. I excluded incorporated cities. Don't want to deal with any extra red tape that I wouldn't want to have to, and it also is good for the wildlife. And I excluded current riparian habitat for obvious reasons. And this was done in 2 phases. First phase being the statewide phase, which means that all the criteria that apply to the entire state are done in phase one. This was completely automatable, if you wanted to say that. And I'm not going to go into each of these data sets. You can find them in my paper if you wanted to take a look at them in detail. But this sort of shows you what it looks like at a high level and all the different data sets that I ended up using. Phase two happens after phase one is complete. So after phase one is complete, you end up with this much smaller data set. And then I chose two areas out of this data set, from which I was then able to download NDVI data, that being the normalized difference vegetation index data, which shows us the plant health over time for these areas. And these are all the rain stations in Arizona, and I was able to get rainfall data from a couple of stations that were very near to these sites, and of course elevation data. So the methodology is what you might expect. You download, or you determine the criteria based on research. You download the data. You import that data into some GIS program, in this case, ArcGIS Pro, and you perform a lot of map algebra, which is, in this case, is mostly like overlays and select by locations and clippings, things of that nature. Nothing too complex here. And it's recursive. As you apply each set of criteria, the resulting data set gets smaller and smaller and smaller, which is what we're looking for. Even that, I knew it was going to reveal too many sites because I intended on doing field work. So I wanted to get it down to just 2 different sites, which is phase 2. These 2 different sites were manually determined by me because I was looking for clusters on a map, and you could have done that programmatically. So I identified 2 main clusters, and then I downloaded the NDVI data and historical rainfall for those 2 clusters, and then generated a suitability map based on that, which we'll see. And then I physically inspected that, which we'll see as well. So the results. Well, you start out with something like this. This is all the ephemeral and perennial streams in Arizona that are greater than 2 miles in length. And if I were to take off the 2 miles in length, this would just be almost solid blue. There's that many. Then after you apply all these criteria in a sort of a recursive fashion, then you end up with this. And this basically, you can see these little dots here. It's a little hard to see on this map. I'll show you in just a minute what it looks like. A cluster of sites here and a cluster of sites down here. And there's here and there's others scattered throughout the state. So the final suitability map kind of looks like this. We have 2 main clusters, one called the Mojave cluster, that I call the Mojave cluster because it's in Mojave County. The other one called the Cochise cluster because, as you guessed, yes, in the Cochise County. And you can see there are 2 different streams right near each other. These are probably about a mile from each other. These are about 1.5 miles, 2 miles from each other. So that allowed some redundancy in this. If one of these didn't work out, maybe I can go to the other one and check it out. And we're going to find out that that actually plays a very important role here. So physical inspection. When I went down to visit these in March, I visited the Cochise cluster in March. And as a reminder, the Cochise cluster is the one that's near the Mexico border. And you can see that this goes through a highway, goes under a highway. So there's some infrastructure built already. This is about 3,500 feet elevation. It does have the potential to get about 2 inches of max rainfall in a 2-day period. That's the data that I downloaded from the rainfall station there. The NDVI data is steady, no changes over 20 years. And you can see right here, this is where it goes. It's wide here at the road, but then it narrows to be about 2 or 3 feet. And it curves off to the right here. You can see like where those trees are. And this one looks like it'd be pretty easy to work with because it's not very large. There's a lot of flora already down there. You have good potential for flooding and rain. Probably cottonwood, something like that might work. It's clearly accessible from the highway. There's right there. There's actually a trail cut which you can walk to, which is what I used. And it's near Sierra Vista. So there's equipment and other things there if you need it. I was only able to visit the northern wash in this particular cluster. The southern one I could not get to unless I was going to be bleeding from head to toe because every one of these strands has thorns on them and there was no path cut to that second one, so I did not visit that. So again, the redundancy worked here. In the other cluster, the Mojave cluster, as a reminder, it's this cluster up here near the California border. You can see that this is vastly different. This is what we think of when we think of desert. And this is only about 750 feet in elevation, only gets about 1 inch in a 2-day maximum rainfall event. So it's not, but interestingly, it will flood because it's desert. You can see that it floods. That's what all this silt and sand is a result of, is flooding. This northern wash, it wouldn't work out. It's way too wide. You can see my truck there and it's too shallow. And if you were to try to fill up from edge to edge, you're talking a couple 100 yards worth. It would take an enormous amount of water to even get this thing going. So I would rule out the northern wash. The southern wash down here, however, this is about 18 feet across, and you wouldn't have to fill up to the top. It's got a really, really well-defined bank along it, which goes up about 10 or 12 feet. You won't have to fill up the entire way. So this looks like a really stable area down here. The downside is getting to this area, you need a four-wheel drive to get there. Just a regular vehicle, you're not going to not make it safe for anybody. So this one might work for something like Mesquite, something along those lines. So why then is this focused on artificial versus restoration? Well, the land is already artificially managed. That's what damming is. That's what a city is. All these things, these are artificially managed. These are human managed bits and pieces of the land that we control 100%. The issue with restoration is there is no pathway for a complete restoration unless you were to remove the dams. And if we can't do that, so there's no pathway for a restoration effort that I can see, that anybody can see, and nobody's come up with. So they're all very partial. They work okay, but not great. The one here on the top is an artificial riparian habitat near Tucson. This was a water treatment plant, which is where the backwash is. And underneath all this is concrete, but they turned it into a riparian habitat managed by the city of Tucson, and it worked great. This is a restoration effort back east. You can see it's very, very small, but doing ones back east is a lot easier than handling the ones out here in an arid environment here in the west. So I'm focused on artificial habitat, 100% managed, engineered, human managed artificial riparian habitat. Use the same word there a couple times. When we look at the selection factors that I used, they all were very important to figure out what was actually needed. The length of the washes was important, of course. The land ownership, we want public land if all available here, so we have some funding and work with K through 12 and universities. Non-incorporated land is better for wildlife. You don't have cities and people around all the time, et cetera, et cetera. The marginal selection factors, the ones I would not use in the future, is wildfire. Oops, I hit the wrong button. Is wildfire. So what we want to use there is prescribed burns. That's what they use down in the San Pedro riparian area. These are pictures that my wife took in March when I was down there. And it talks about the benefits of prescribed burns down there, which is, so having it near a wildfire, a natural wildfire is not a good idea. Plus they're actually fairly rare in the desert area. They're common in the transition zone and the high elevation, but not in the desert. And I wouldn't use Indy value information in terms of a selection criteria. That's interesting information after the fact, to see if it changes after the installation of a riparian habitat. So this is a multidisciplinary and a very large project. So you want to, it's great for a large school or a couple of large schools to work together on, because you would use all the different, well, not all of them, but a lot of different departments within a university, such as the U of A or ASU, something along those lines. You want to use engineering, geology, geography, life sciences. Everybody would want a hand in this. And it's great because you'd have some funding from the state, you get to work with the state, and then you could have grad students involved, researchers involved, et cetera, et cetera. It's great for the school, it's great for the land, everybody wins. There are some politics you'd have to deal with in terms of fees and applications and litigation, but that is like anything else, you just plod along until you figure that out. So the final thoughts here, this methodology is plausible. It will work. You can, you would have to tune it. You can automate it. You can make it just where it's very, very precise and get it right where you need it. But all that being said, you still need to perform the actual field work. You have to go out there and take a look, because in each case, only one out of the two washes were suitable, at least for me. I suspect that would happen quite a bit. It would look great on paper, but not so much in person, because some of that data is lacking. The other thing is, when we go out into nature, we like seeing wildlife. We like knowing that the wildlife is out there. It makes us feel good knowing that the wildlife is flourishing in the state, particularly in the riparian areas in Arizona. Why is it so important to have the riparian areas in Arizona work? Because that's where 75% of all bird species live that aren't in cities. So you take away, for instance, the riparian areas, and you do away with 75% of all bird species in the state. They will not exist outside of cities, which is an artificial managed habitat. So let's bring that out into the actual desert itself. So we have the ability to actually make this thing happen. The question is, do we have the will? Thank you.